Welcome to day 29, Static versus Dynamic Scoping. In this session, we will explore the rules of scoping, compare static and dynamic scoping, and dive into real-world examples in programming languages. Let's start by understanding what scoping is. Scope defines the region in a program where a variable can be accessed. It governs the visibility and lifetime of variables, helping avoid naming conflicts in the code. Understanding scoping is crucial for writing clean and maintainable code. Now let's look at the two primary types of scoping, static and dynamic. In static scoping, the scope is determined by the structure of the source code and is resolved at compile time. In dynamic scoping, however, the scope is determined at runtime based on the execution call stack. Both approaches have their pros and cons, which we will discuss next. Static scoping, also known as lexical scoping, determines variable binding based on the program's source code structure. This means that when a variable is referenced, the compiler will resolve it by looking at the position of that variable in the code. Let's look at an example from C. Here we define a global variable x and a local variable x within function 1. The local variable shadows the global one within function 1, but outside of it, the global variable x is used. On the other hand, dynamic scoping determines variable binding based on the execution call stack at runtime. This means the value of a variable is resolved based on which function is currently executing. For instance, in libs, the variable x takes the value defined in the most recent function in the call stack, making it dynamic. This can sometimes result in unpredictable behavior, but it offers flexibility in certain use cases. Now let's compare static and dynamic scoping. In static scoping, the variable binding is resolved at compile time, making it easier to predict and debug. Static scoping is more commonly used in modern programming languages. On the other hand, dynamic scoping resolves variable binding at runtime, which can lead to unexpected results and harder debugging. Dynamic scoping offers flexibility but requires more careful management. Most modern programming languages such as C, C++, Python, Java, and JavaScript use static scoping due to its predictability and ease of use. However, languages like Lisp and Perl allow for scoping, providing more flexibility, especially in specific scenarios. Understanding the scoping rules of the language you are working with is essential for writing effective code. Scoping plays a significant role in debugging, performance, and readability. With static scoping, it's easier to track where variables come from and to ensure that their values are predictable. It also allows for better optimizations during compilation. Dynamic scoping can lead to unexpected results, making it harder to debug and optimize the code. It's important to consider the impact of scoping rules when designing your programs. So, when you should use static or dynamic scoping. Static scoping is generally preferred for large, complex systems because it offers predictability, easier debugging, and better performance. Dynamic scoping can be useful in smaller, flexible systems or in specialized languages where you need more dynamic behavior. Each approach has its place depending on the specific needs of the project. To summarize, static and dynamic scoping are two different ways of managing variable binding in programming languages. Static scoping is more common and predictable, making it easier to understand and debug. Dynamic scoping, while more flexible, can sometimes lead to unexpected behaviors, which can complicate debugging. Choosing the right scoping model depends on your project requirements and the language you are using.